Hello everyone, my name is Michelle, and today we're going to be going over rationalizing radical expressions, specifically two-term expressions in the denominator. So let's go over what we learned last lesson. Last lesson we went over rationalizing one-term radical expressions, and what that looked like was x, which is any expression, over the square root of y, where y is also any expression. And the way we'd rationalize that is we'd multiply the top and the bottom by the square root of y, and we get x times the square root of y divided by y. So yeah, as you can see, the radicals in the denominator cancel out. So that is with one term. Today we're going to be dealing with two-term radical expressions. And the way that's going to look is we're going to have x, which is any expression, over n, any number, plus or minus the radical y. And the way we're going to rationalize these denominators is by, depends on whether or not that plus or minus is plus or minus. So, our first example, if it is plus, we are going to take the conjugate, which means we are going to flip the sign. If it's positive, we'll flip it to negative, and if it's negative, we'll flip it to the positive. But only for the radical. I'll show you. So we're going to multiply the top and the bottom by n minus the square root of y. And as I said before, notice how we flip the sign, but not for the n. The n will still be positive, but we only flip the sign in front of the radical. So that is if the radical is positive in our denominator. If the radical is negative, it's going to be very similar. We're going to do, if we have x over n minus radical y, we're going to multiply the top and the bottom by n plus radical y. And again, you see that we are taking the conjugate, which is the sign flipped. Alright, so let's go over some examples, and hopefully this concept will be very clear to you after we go over these. So let's start with example A, 2 over 2 plus the square root of 3. So we want to rationalize, and we see that the sign in front of our radical is a positive, which is that plus. So since that is positive, what we're going to do, we're going to multiply by the conjugate, and the conjugate will be negative. So we'll do 2 minus square root of 3. Top and bottom. And the reason we do the top and the bottom is all because of balance. Because technically if we have the same expression on the top and the bottom, then it will equal 1. And that would mean that we're technically multiplying by 1. And this idea of technically multiplying by 1, but to simplify something, is called a well-chosen 1. But that's kind of unrelated. You don't really need to know that. Alright, so let's continue on our problem. We are multiplying by the conjugate on the top and the bottom. So now all we're going to do is normal multiplication. So let me rewrite everything. We'll have 2 times 2 minus the square root of 3 over 2 plus the square root of 3 times 2 minus the square root of 3. And actually, I am going to have to write a little bit over here because I'm running out of space. Alright, so the numerator, we're going to distribute that 2 to the numbers inside the parentheses. So we're going to do 2 times 2, which is 4. And then 2 times the negative square root of 3. And that is going to get us negative 2 times the square root of 3. In the denominator, we're going to multiply the 2 by the 2. That's going to get us 4. And then we're going to multiply the 2 by the negative square root of 3. And we're going to get minus 2 the square root of 3 times the square root of 3. Next, we're going to multiply this square root of 3 by the 2. And we're going to get plus 2 times the square root of 3. And then we're going to do the square root of 3 times the negative square root of 3, which is just negative 3, because the square roots cancel out. Alright, so now we are going to simplify further. We can't simplify the numerator right now, but we can see that this negative 2 times the square root of 3 and the positive 2 times the square root of 3 cancel out. So that's just going to get a 0. And then we see that the 4 and the negative 3 are like terms. They are both constants. So we can combine them, do 4 minus 3, and that'll get us 1. So let's rewrite our entire expression. We'll have 4 minus 2 times the square root of 3 over 1. And remember that 1 is from the 4 minus 3 right here. And we can remember that we don't actually need to write over 1. So let me just erase that. And so our final answer would be 4 minus 2 times the square root of 3. Alright, so on to example B. So we have 1 plus the square root of 6 over 1 minus the square root of 6. So we're going to focus on rationalizing the denominator. So we're going to look at the sign in front of the radical in the denominator. And in this case, it is negative. And we are going to take the conjugate, which is the opposite sign. So that would be positive. So we're going to multiply the top and the bottom by positive square root of 6. Next, I'm going to rewrite that. Over here, we're going to have 1 plus the square root of 6 times 1 plus the square root of 6 over 1 minus the square root of 6 times 1 plus the square root of 6. So let's simplify the numerator. We're going to do 1 times 1, which is 1. 1 times the square root of 6, which is positive square root of 6. And then this square root of 6 times positive 1, which is plus square root of 6. And then square root of 6 times square root of 6, and the square roots cancel out, and we will just have positive 6. Next, we're going to simplify the denominator, and I'm going to teach you a quick little trick that's going to make this a little less tedious. So when we are multiplying two conjugates together, a little trick we can do instead of multiplying everything out like we just did in the numerator is the answer will be the same if you just multiply these the first two and the last two terms of each expression. So if we do that, then we're going to get positive 1 minus 6. And the reason that works is when we are multiplying conjugates together, if you noticed in the last example, there will be two terms that cancel each other out. I believe in the last example it was positive 2 times the square root of 3 minus 2 times the square root of 3. And if you don't see what I mean, I recommend that you just rewind the video a little bit and go back and see where in the denominator we cancel those two terms out. And basically this shortcut, it just takes that canceling part out since it's going to equal 0 anyway. Alright, so we have simplified our numerator and denominator. We can combine like terms, so simplify just a little bit more. And that's going to get us in the numerator 1 plus 6, that's 7. And the square root of 6 plus the square root of 6, which is 2 times the square root of 6, over 1 minus 5, which is negative 5. And I would say that that is our final answer. So some people might say that you're going to need to take the negative out of the denominator, put in the numerator, but it really doesn't matter. Alright, so on to example C. And this is the same example C from earlier, I just had to move everything around a little bit. So that's why it seems different. So example C, we have the square root of 2 plus the square root of 3 divided by 2 plus the square root of 2. We're going to look in the denominator and see that the sign in front of our radical is positive. So we're going to multiply by the conjugate, which will be negative. So multiply the top and the bottom by 2 minus the square root of 2. And honestly, since I'm trying to save space, we don't need to rewrite it, but we can multiply just from here. So we have, in the numerator, the square root of 2 times 2, which will be 2 square root of 2. Then we have the square root of 2 times the negative square root of 2, which is negative 2. Remember, these square roots will cancel out. Then we have the square root of 3 times positive 2, which is positive 2 square root 3. And then we have the square root of 3 times negative square root of 2. And those are going to multiply, and we're going to get the square root of 6. And then all of it over the denominator, and we're going to use that trick I just said earlier. We're going to multiply the first terms and then the second terms. And that is going to give us 2 times 2, which is 4. And then positive square root of 2 times negative square root of 2, which is negative 2. Again, that trick only works if you're multiplying two conjugates together. Please don't do that with everything you see. So we can't actually simplify the numerator right now, so that's going to stay a mess. But what we can do is do the 4 minus 2 in the denominator, and that will get us positive 2. I'm just going to... Bam. Alright, so at this point, you could say that that is your final answer, but if you really want to simplify it a little more, what you could do is split up that expression in the numerator. So split it up by what we can divide by 2 and what we can't divide by 2. And obviously, the terms we can divide by 2 are going to have some multiple of 2 of them. So those are going to be all of these terms. And the term that we can't divide by 2 will be the square root of 6. And so we're going to split up the fraction. And we're going to divide that first parentheses by 2. So we're going to get 2 square root of 2 divided by 2, which will just be the square root of 2. And then negative 2 divided by 2, which is negative 1. And then positive 2 times the square root of 3 divided by positive 2, which will be positive square root of 3. And then we have that last term that we can't divide by 2, so we're going to keep it in fraction form. We're just going to say minus the square root of 6 over 2. And you could rearrange some of the terms to make it look a little bit prettier, but for simplifying, this is as simple as it gets. So this mess right here, the square root of 2 minus 1 plus the square root of 3 minus the square root of 6 over 2 is our final answer. Alright, so that is all for today's lesson. Thank you so much for watching, and I hope you learned something today. Have a great day.